In this lesson, we're going to learn about compound inequalities. So if you remember, last week we were working on just solving multi-step inequalities, and we're basically just trying to find the value of x using all the same different processes that we would with solving regular inequalities. But today, now we're going to solve compound inequalities. And a compound inequality is basically two inequalities separated by the words and or. So we will have two inequalities per problem now, and we're either going to be seeing the word or separating the two inequalities, or the word and. Or inequalities, which we're going to work on today, have a tendency to graph pointing in opposite directions. So they graph outward. For example, x is less than or equal to -2, or x is greater than 3. So what we would do to graph this inequality is just graph both of these inequalities on the same number line. So x is less than -2 would be a closed circle at -2, and the solutions would be to the left. Or x is greater than 3, that would be an open circle at 3 with the solutions to the right. This worksheet and on the next page, it's going to ask us to use something called interval notation. That is something we will learn in Algebra 2. We can ignore that for our notes and for our practice worksheets and for our tests. We're not going to be testing on that. So you can just ignore that. What we're going to be doing is just solving and graphing compound inequalities. So direction, solve, graph, and then we can skip this. We're not going to be using interval notation. So number 1 says x minus 4 is less than -7, or 2x is greater than or equal to 12. So what we do is we just solve each one for x. It's not like a choice. We don't get to look at this and decide, oh, I want to solve this one or this one. It's not like that. You solve both of them by isolating x. The first one we would just add 4 to both sides, and -7 plus 4 is -3. So one of the endpoints is x is less than -3, and then you write the word or, and then you solve the other one. To solve the other one, we would divide both sides by 2, and we get x is greater than or equal to 6. So then on our graph, we would just graph both of these inequalities. This would be an open circle at -3 with the solutions to the left, and a closed circle at 6 with the solutions to the right. Next one, we do have to be careful when we do divide by a negative. We still will flip the sign following all those same rules. So the less than or equal to symbol will flip around and turn into a greater than or equal to symbol because we're dividing by a -3, and -9 divided by -3 is +3. So that's the first one. Or the second one, we would subtract 5 from both sides and get x is less than 1. So less than 1, open circle at 1, solutions are to the left. Greater than or equal to 3, closed circle at 3, solutions would be to the right. As you move forward, we're going to be required to do some more work here. So this is going to require 2 steps. We would subtract 9 from both sides and get 2x is greater than 17 minus 9 is 8. And then we would divide by 2 and get x is greater than 4. So that's one answer. Or the other answer, we would subtract 10 from both sides, get 5x is less than 0. And when we divide both sides by 5, we're going to get 0 because 0 divided by 5 is 0. And overall, my answer would be x is less than 0. So we've got 2 inequalities to graph. Anything greater than 4, that would be an open circle at 4, solutions to the right. Or anything less than 0, that would be an open circle at 0, and solutions would be to the left. All right, working our way down, number 4, we're solving for x for both of these. So step 1, add 14 to both sides. We get 7x is greater than or equal to 14. Divide by 7 and get x is greater than or equal to 2. And for the other one, subtracting 5 from both sides, 4x is less than or equal to -8. And dividing by 4, we are not dividing by a negative number, so the sign will not flip. It'll be less than or equal to. negative 2. So here's my two answers. X is greater than or equal to 2. That's a closed circle at 2, solutions to the right. Or X is less than or equal to negative 2, closed circle at negative 2, solutions are to the left. And then the last one that we have, we've got negative 3 times the quantity 2x plus 1 is less than negative 15. And you have an option here. You can use the distributive property if you want. You also could get rid of that negative 3 right from the start by just dividing by negative 3. Your choice. You don't have to do it this way, but if you do it this way, these negative 3's cancel, and you're left with 2x plus 1. But don't forget, we did divide by a negative here, so the symbol is going to change directions. And then we get 2x plus 1 is greater than 5. Subtracting 1 from both sides, we get 2x is less than 4. Dividing by 2, and we get x is greater than 2 as an answer. Now maybe you didn't want to do it that way. Maybe you like the distributive property. So if that's the case, then you would distribute here. Negative 3 times 2x is negative 6x. Negative 3 times 1 is negative 3. And then you would solve this one out. Negative 6x is less than negative 15 plus 3 is negative 12. And then when you divide by the negative number here, your sign flips at this point. It turns into x is greater than 2. Or the other one, 1 minus x is greater than or equal to 5. We would subtract 1 here and here. We get negative x is greater than or equal to 4. And we need this negative to go away. So the only way we can do that is by either dividing or multiplying by negative 1. There's technically, it's negative 1x. So I like to divide both sides by negative 1. And when I do that, I will flip the sign. So it goes from a greater than or equal to a less than or equal to. 4 divided by negative 1 is negative 4. So on my number line, I would graph both of these endpoints. Greater than 2 would be an open circle at 2. Answers would be to the right. Less than or equal to negative 4 would be a closed circle at negative 4. Answers are to the left.